right, so this is the normal approximation, and how do we use it in practice? Well, what we know is that if we want to find the probability that x is in some range, okay, so normal approximation. Okay, so normal approximation to the distribution of the sample sum or sample mean of draws with replacement from a box of numbered tickets, draws at random, and the probability. So let's call this random variable x. The probability that x is in some range. I'm going to call these values a is less than or equal to x is less than or equal to b. These are not the same a and b that we had before. Before these were representing the constants in some transformation. This is just some range of values of x. That this gets this, or we'll write it this way, is approximately the area under the normal curve between A and B converted to standard units. So how do we convert A to standard units? A minus, is A a random variable? A is a constant. We're talking about values of this random variable. Okay? So we want to convert A as a value of x to standard units. So it's A minus the expected value of x over the standard error of x. And B minus expected value of x over the standard error of x. Okay, so this is A converted to standard units. This is B converted to standard units, because we're talking about the random variable x. It's standard units of x that we care about. Okay. And this approximation gets better and better and better the larger the number of draws is. Approximation can be terrible if the number of draws is small, but eventually it gets good. Okay, so if x is the sample sum, then what is this in symbols? Let's suppose we're talking about so let's let x be the sample sum of n draws with replacement. Then Ex is equal to what? Right, the standard error of x would be the root n times the standard deviation of the box. Yep. And so to convert A to standard units, we're looking at A minus n times the average of the box divided by the square root of n times the SD of the box. Right? And similarly for B. Okay? So if we convert them to standard units and then look at the area under the normal curve for that range, that will be an approximation to the area under the probability histogram for the random variable itself. So that's kind of what was going on in this picture. There's a couple of things that are missing that I want to talk about. Let's first of all look at okay, so here is the standard normal curve. And this applet lets us highlight a range of values. So if we wanted to know the area under the normal curve between minus 0.3 and plus 4, we could just do that and read off the area. It's approximately 61.8%. Okay? So if we were looking at the distribution of the sample sum of a bunch of draws from a box of numbers, and we wanted to know what's the chance that that sample sum is between minus 0.3 and 4 after you convert to standard units, that probability would be approximately 61.8%. Okay. So what is the value minus 0.3 in standard units correspond to in original units? So it's minus 0.3 standard errors from the expected value. So it's 0.3 standard errors below the expected value. Right? Okay, and this is 4 standard errors above the expected value. Okay. Yeah. That's this. In the special case, that what x is the sum of n draws at random with replacement from a box of numbered tickets, right? Because the expected value of that is n times the average of the box, and the standard error is the root n times the standard deviation of the box. All right, it might be easiest to do an example. Okay. If you want to find the area under the normal curve for an arbitrary range, you can do it using this applet. There is also the probability calculator has, look at tools, the probability calculator that you've seen, this normal distribution. So this is the area under the normal curve. Standard normal curve has mean 0 and standard deviation 1. Then you can use this to find a range as well. We just did minus 0.3 to 4. And we got 61.8%. This is giving us a few more digits of accuracy, 61.788%.